Hello dear students, this is Lokesh Babu. Welcome to my channel Lokesh Maths Hub. Thank you for watching my videos. See dear students, in the previous classes we discussed about the Fourier series. Now in this class, in this lecture, in this video, we are going to discuss about the calculus part. In this, we are going to discuss about Rolle's theorem and Lagrange mean value theorem, Cauchy mean value theorem, and its geometrical interpretations, and Taylor's theorem, and Maclaurin's theorem, and problems. So these are the topics. In this, I will take a total of 4 to 5 classes. It means 4 to 5 lectures, 4 to 5 videos. So in these videos, I will explain in detail about Rolle's theorem and problems, and Lagrange's mean value theorem problems, Cauchy mean value theorems and problems, and Taylor's theorems and Maclaurin's theorems and its problems. Right? Okay. So all of you, please take pen and paper, pen and notebook, and write down, note down whatever I am teaching, and practice these all theorems and problems at least 2 to 3 times, such that you will get very confidently and perfectly. Right? Okay. And don't skip this video. Please watch from the starting to end. Then only you can understand. Because this is calculus part. So each and every step you have to understand. Right? Okay. Now let's start the class. So the first of all, Rolle's theorem, Lagrange mean value theorem, Cauchy mean value theorem, and its geometrical interpretation. In this, let us discuss about Rolle's theorem. Okay. In this Rolle's theorem, the statement of Rolle's theorem is here. Let f of x be a function which is defined in the closed interval AB, and it satisfies the following conditions. First one, f of x is continuous and closed interval AB, and f of x is differentiable on open interval AB, and f of a equal to f of b. Then there exists at least one value c belongs to a comma b such that f dash c equal to 0. See here, f of x is defined on a closed interval AB, and it must satisfy the 3 conditions. What is the first one? F is continuous in the closed interval AB, and f is differentiable on open interval a comma b, and f of a equal to f of b. Then there exists at least one c belongs to AB such that f dash c equal to 0. Okay. See, it means, let us see here. Let us, this is the x-axis and this is y-axis, and this is the curve y equal to f of x curve. This is y equal to f of x curve. This curve lies between the points A and B. Then, according to Rolle's theorem, f is continuous each and every point between A and B. So first point is f is continuous in the closed interval a comma b, right? And second point is this function f is differentiable in open interval a comma b. This is differentiable in a comma b. And third condition is at this point f of a equal to f of b here. F of a equal to f of b. Here this point is a comma f of a actually, right? So this point is, yeah, this point is in bracket A comma f of A. Right. This is A comma f of A point. And this is B comma f of B. Okay. This is A comma f of A point, and this is B comma f of B. Now, what we are discussing, first one is f is continuous in this closed interval, and f is differentiable in this interval, and f of A equal to here this point is B comma f of B now, and here B comma f of B, A comma f of A, and f of A equal to f of B, f of A equal to f of B. Then at a point C, we can draw a line. It means a tangent. We can draw a tangent. It means if this tangent is parallel to the x-axis, this line is parallel to the x-axis. If a line is parallel to x-axis, then the slope at this point is obviously 0, right? See, if a line is parallel to x-axis, then the slope at the point C is equal to 0, because here A f of A, this is B f of B. What is the formula of slope generally from intermediate? M equal to y2 minus y1, y2 minus y1, y2 minus y1 by x2 minus x1, right? This is a slope formula. Y equal to m equal to y2 minus y1 by x2 minus x1. But this is, let us suppose this x1, y1, and here B, no, first point is B in this B comma f of B, f of yes. Now observe this, f of A and f of B, A comma f of A, B comma f of B. But here f of A equal to f of B, third condition. Since f of A equal to f of B, x1 y1, x2 y2. Okay, x1 y1, this is x2 y2. So substitute in this. So y2 minus y1, y2 is f of B, and y1 also f of B, because f of A equal to f of B, right? Did you understand? Y2 is f of B minus y1 also f of B, because f of A equal to f of B, f of A equal to f of B. So y2 minus y1 is nothing but y1 minus y1 or y2 minus y1. So totally this value is equal to 0. So what you understood? If a line is parallel to the x-axis, try to understand clearly. If the line is parallel to the x-axis, then the slope is compulsory 0. By using this formula, y2 minus y1 by x2 minus x1, and here y2 value also y1, so y1 minus y1 is 0, obviously, right? It means you note down here it is not there. I am dictating, you please write down. It means slope of the tangent. Here this is slope, f dash is slope of the tangent. This slope of the tangent of a line at this point C, it means slope of tangent of a line at the point C is obviously it is nothing but the derivative of the function, nothing but the derivative of the function at the same point. It means slope of this tangent, slope of the tangent is nothing but the derivative of the function, right? Okay, obviously it is the derivative of the function. So therefore, here the slope is equal to 0. So this is the geometrical interpretation. Say if a function f is continuous in the closed interval AB, and if it is differentiable in open interval AB, and f of A equal to f of B, then there exists a C belongs to A comma B such that f dash C equal to 0. If you take the figure is like this, in this interval, you can draw the tangent is here and here and here, right? So obviously it is continuous in every point and differentiable. Then there exists a C belongs to AB such that the tangent is parallel to this x-axis, and there exists a C belongs to A comma B such that f dash C equal to 0. Okay. Now, by using this, we can this formula, you can solve. Let us solve some problems. Now, see here, before going to solve some problems, so we should recall some points which are already we discussed in the, from the intermediate level. So what is this? A polynomial function is everywhere continuous and differentiable. If you take any polynomial, f of x equal to x square plus 2x plus 1, that polynomial is always continuous and differentiable. So note down this point. Every polynomial is a polynomial function is everywhere continuous and differentiable. And the exponential function means e power x, sin x, cos x, e power x, sin x, cos x. These functions also everywhere continuous and differentiable. Second point. Third point, the sum, difference, and product of these continuous functions is continuous. Sum, difference, product of differentiable function is differentiable. Very interesting, right? Sum, difference, product of continuous functions is continuous, and sum, difference, and product of differential functions also differentiable. Okay. Now, tan x is not continuous at x equal to pi by 2. Why? Because tan x is not continuous in this, because you can write tan x equal to what you can write? Tan x equal to tan x is equal to sin x by cos x. Okay, I'm writing, please try to understand, sin x by cos x. Okay, now what tan x at these points? No, let us suppose I will take 1 point pi by 2. Sin pi by 2, what is sin pi by 2? Sin 90. Sin 90 is here 1, right? 1 by cos 90. Cos 0 is 1, cos 90 is 0, so 1 by 0. 1 by 0 is obviously nothing but infinity. What is 1 by 0? It is infinity. So it means limit does not exist, right? So if tan x at this point x equal to pi by 2, sin x by cos x, and sin 90 is 1, cos 90 is 0, so 1 by 0 is infinity. This is not existing, therefore it is not continuous, right? Next, fifth point, mod x is not differentiable at x equal to 0. Actually, if f of x equal to mod x is continuous, it is continuous at x equal to 0. If you take mod x definition is, what is mod x definition? Minus x if x less than 0, plus x if x greater than 0. Okay, mod x value is minus x if x less than 0, plus x if x greater than 0. So at x equal to 0, obviously this is 0, so it is continuous. But if you you test the differentiability, the right derivative is limit 0 plus h minus 0 by h, you will get plus 1, and left derivative is f of 0 plus h minus f of 0 h by minus h, that is equal to minus 1. So if you observe differentiability, left derivative is, you will get plus 1, and right derivative you will get minus 1. So left derivative is not equal to right derivative. So that is why this is not differentiable, right? I think you understood clearly. Okay, very good. Now Next, say if f dash x is infinity, it means if you take any value f of x, by differentiating if f dash x is infinity, simply it is not differentiable. So the simple technique is just if f dash x is infinity, then you can say simply it is not differentiable. Okay. If f dash x exists, for example, x square is there. Let us suppose f of x equal to x square. What is f dash x? 2x. It means derivative exists. Here, for example, you take this one, f of x equal to 2x minus 1, 2x minus 1, whole power of 1 by 2. Find f dash x value. What is f dash x value? This is root x. 2x minus 1, 1 by 2 means root x. So this is 1 by 2 root x into 2x differentiation is 2. At this point, we want the limit extends to 1 by 2 f of x. Our question is, if f of x equal to 2x minus 1 power 1 by 2, find limit extends to 1 by 2 f of x. If I substitute extends to 1 by 2 here, x is 1 by 2, then what will happen? 1 by 2, 1 by 2, 2 to cancel, 1 minus 1, 0, 1 by 0 is infinity, this is. So the limit does not exist. This is not differentiable. Okay. So in this way, what you can say? We can say easily a function is differentiable or not differentiable. Okay. Right. Now, let us see one problem. Verify Rolle's theorem for the function f of x equal to x square minus 5x plus 6 on a comma b is 2 comma 3. Now, to verify the Rolle's theorem for this function, if you observe this function, see all of you, this is a polynomial function. F of x is x square minus, it is algebraic functions or polynomial function. This is a polynomial in x. Therefore, obviously, this is continuous and differentiable by the node 1. The previous slides, node 1 is there. In that, we discussed every polynomial is continuous and differentiable. So this is a polynomial, so it is continuous and it is differentiable. Okay, so it is first condition. What is the Rolle's theorem? F is continuous is over. Second condition is f is differentiable also over. Right? What is Rolle's theorem conditions? First condition is f is continuous. Okay. What is second condition? F is differentiable. Yes, since it is polynomial, differentiable on R. Okay. Two conditions over. Third condition, what is third condition? F of A equal to f of B. What is A? A is 2. B is 3. Substitute 2 in the place of x, you will get f of A. Substitute 3 in the place of x, you will get f of B. Now let us see. See, I am substituting f of 2 in the place of x. Then 2 square minus 5 2 plus 6 equal to 0 you are getting. And I am substituting 3 b value in the place of x. Then 3 square minus 5 into 3 plus 6, 9 minus 15 plus 6, obviously 0. So f of A equal to f of B. Okay. Now what you understood from this, we can understand f of A equal to f of B. Third condition also over. Right? First condition is continuous. Second condition is differentiable. Third condition is f of A equal to f of B. Next what? Then there exists a C belongs to A comma B. Then there exists a it means all the three conditions of Rolle's theorem are satisfied. Therefore, there exists a C belongs to A comma B such that f dash C equal to 0. What is f dash C? First of all, find f dash x. F of x is obviously, you know, the above. F of x is, this one is f of x. Now, what is f dash x? 2x minus 5. Okay. F dash x is, this is f of x. F dash x is differentiation of this is 2x minus 5. This is f dash x. I want f dash c. So f dash c equal to 2c minus 5 equal to 0. From that, c equal to 5 by 2. It is nothing but 2.5. 2.5 e lies between 2.5 this 2.5 lies between exactly 2 comma 3. Therefore, what we can conclude, if f of f is continuous and f is differentiable and f of a equal to f of b, then there exists a c belongs to a comma b such that f dash c equal to 0. Okay, it means Rolle's theorem is verified. So in this way, we can solve a number of problems. Okay, and I will give you one homework problem. It means it is one assignment problem for you. Please solve after watching this video. You can understand easily. One second. Yeah. So please write down this problem. Verify Rolle's theorem for the function f of x equal to x into x plus 3 into e power minus x by 2. And take x into x plus 3 as u and this is v. And check the continuity, differentiability and f of a equal to f of b. Then find the c value by using f dash c equal to 0. Right? So I think, I hope you understood this class, this lecture clearly. In the lecture 2, it means next coming video, we will solve some more problems on roles and we will discuss about the Lagrange's mean value theorem and some problems. Okay. Thank you. Thank you for watching. If you like this video, please uh, share and subscribe my channel. Okay. Thank you. Thank you all.